Let's just dive right in, shall we? Today, we're taking a fascinating journey inside one of the most common, yet completely misunderstood engines on the road today, the Honda R18A. You know, the 1.8-liter i-VTEC engine found in the Honda Civic Reborn. Welcome to The Explainer. We're going to tear this thing down and uncover some truly brilliant engineering hiding right under our noses.
So we're kicking things off with a pretty provocative claim from a recent teardown by Speedcar 99, and it sets the stage perfectly for us. There's this super common sentiment floating around the automotive community, right? The idea that newer, smaller, highly optimized engines are just junk, that they completely lack the rugged soul or that bulletproof, overbuilt quality of engines from the golden era.
Which leads us to the big question. Is the Honda 1.8-liter R18A actually a step backward, or is it secretly a masterpiece of modern engineering? Well, to really answer that, we've got to push past the internet opinions. We need to look directly at the physical anatomy and the revolutionary digital brains of this engine. We're going to see exactly what's happening inside those cylinders and figure out why on earth the engineers made some of the seemingly bizarre choices they did.
Okay, Section 1, the Honda R18A teardown, physical anatomy. Let's get into the hardware.
Just picture this in your mind for a second. A highly realistic, transparent 3D cutaway of this engine running beautifully right in front of us. When you look at the macro-level blueprint, we're dealing with an incredibly lightweight aluminum block, just 223 pounds. But despite that small footprint, it packs a punchy 10.5-to-1 compression ratio, putting out 140 horsepower at 6,300 RPM. This is an engine purpose-built to do exactly what a daily driver needs, giving you reliable power without unnecessarily weighing the car down.
Now, let's address the controversies, because there are a few. Critics love to point out that the timing chain in this setup is literally thinner than a bicycle chain. And honestly, you might be wondering, how on earth does that handle the stress of the i-VTEC system? Well, look closely at the rest of the components. Honda paired this super narrow silent chain with a heavy-duty hydraulic tensioner and really reliable plastic timing guides. So instead of just using sheer brute mass, they used precision engineering to flawlessly manage those mechanical forces, completely eliminating the need for those bulky older timing belt designs.
Moving on to Section 2, Pistons and Moving Parts, Reducing Friction.
As we move deeper into the engine block, you really start to see Honda's absolute obsession with reducing internal resistance. If you zoom in on the ultra-detailed texture of this piston assembly, you'll notice a really specific polka dot pattern of molybdenum coating right on the piston skirts. Why polka dots, you ask? Because that pattern actually traps microscopic pockets of oil, drastically minimizing friction against those high-rigidity cylinder walls during that relentless four-stroke cycle. Add in some high-strength forged cracked connecting rods, and boom, you've got a remarkably robust, shockingly low-friction rotating assembly.
All right, Section 3, the engine lubrication system, the lifeblood.
But think about it. How do all these high-speed physical components survive that immense friction without just instantly disintegrating? Well, just like heavy-duty diesel engines or nuclear-grade backup machinery, the actual longevity of the R18A relies entirely on a steadfast mechanical gear pump. You can see how the pump is constantly, actively pulling fresh oil straight up from the lower oil sump. And as that internal driving gear rapidly rotates, it forces that vital fluid out under intense pressure. This continuous flow forms an imperceptible but absolutely essential protective barrier over the engine's main bearings, that super narrow timing chain we just talked about, and the precision-balanced crankshaft. It's quite literally the engine's lifeblood.
So, the crucial takeaway here is how this pressurized oil is specifically directed. It doesn't just splash around aimlessly in there. The engine uses incredibly precise piston cooling jets. These jets aggressively spray oil directly onto the underside of the moving pistons, actively pulling heat right away from the aluminum cylinders to prevent any warping under high loads.
But here is where the oil system becomes truly brilliant. This oil pressure isn't just for cooling and lubrication. It actually acts as a literal hydraulic trigger. When the engine hits the right conditions, a specific sensor, the VTEC switch, opens up a pathway, sending a massive surge of pressurized oil directly up into the cylinder head to actuate the rocker arms.
Which brings us to Section 4, Rethinking the i-VTEC System, a New Approach.
To really grasp the genius of the R18A's completely redesigned i-VTEC, you first have to understand its primary villain, which is pumping losses. Imagine trying to take a really deep breath while pinching your nose and covering half your mouth. It's tough, right? That restriction is exactly what happens in a normal engine when you're cruising on the highway with your foot barely on the gas pedal.
The nearly closed throttle butterfly chokes the engine, creating this massive vacuum that forces the pistons to fight incredibly hard just to pull air in. And that fight absolutely robs traditional engines of their fuel economy.
So what did Honda do to fix this? Well, they flipped their own script entirely. In older sports cars, VTEC famously kicked in at high RPMs to give you that screaming race car performance. But in the R18A, VTEC activating actually means you are shifting into a high-efficiency economy mode. When VTEC is off, you're running on normal hot cams, giving you standard punchy performance off the line. But when you hit a nice steady highway cruise at around 3,500 RPM, VTEC turns on. And that engages special low cams designed solely for saving fuel. It's completely backward, but in the best way possible.
Section 5. Drive-by-wire synergy. Digital brains.
Now, to make this reversed VTEC system work without the driver feeling a massive jarring loss of power on the highway, Honda had to introduce a digital brain, and this leads to a brilliant drive-by-wire paradox. Under normal driving, your gas pedal acts exactly like you'd expect. Press it a little, the throttle opens a little. But when economy VTEC engages on the highway, the digital computer completely takes over. Even though your foot is barely pressing the pedal, the computer commands the physical throttle butterfly to swing wide open. This totally eliminates the intake restriction, instantly destroying those terrible pumping losses.
I know what you're thinking. If the throttle is wide open, why doesn't the car suddenly accelerate wildly out of control? Well, that is the magic of those economy cams. Picture the precision of the four-stroke cycle. By keeping the intake valve open late, way into the piston's upward compression stroke, the piston actually just pushes the excess, unneeded air right back out of the 32mm intake valves. The engine is controlling its own speed mechanically by delaying the valve timing, rather than choking itself at the throttle body. So it breathes perfectly freely and only burns exactly the amount of fuel it actually needs.
The results of this, they absolutely speak for themselves. The perfect synergy between this digital drive-by-wire throttle and the mechanical delayed valve closures results in a massive 16% reduction in pumping losses. That is literally free efficiency pulled entirely out of thin air, just through incredibly clever engineering.
So we return to our opening question. Knowing how the physical teardown, those polka dot pistons, the ultra-pressurized oil cooling, perfectly synchronizes with the digital drive-by-wire brains to completely reinvent the combustion cycle, is this engine really just modern junk, or is it a masterpiece of everyday engineering? What you should really take away from this explainer is that true mechanical genius isn't always about making the most horsepower for the track. Sometimes it's about achieving the most elegant, frictionless efficiency imaginable for the everyday driver. Makes you wonder, what other everyday objects are hiding absolute genius right under the hood?